Okay, in this short video, I will show how we can put a proxy in front of Azure AD B2C in order to implement the missing device flow. So the idea is to, from a structural perspective, to have a device like a set-top box which wants to talk to an application. It needs a token for this, and in order to do the sign-in, it basically connects to a device proxy. This is the .NET component which we are having here, which shows a user code. The user code basically asks a user to use a browser to sign in to the device proxy and to Azure AD. And in the back, the set-top box continuously polls the device proxy for an authentication statement. So if we look at this in detail, so once the device is turned on, the set-top box grabs a device code from the device proxy, and the device proxy has an internal database, Redis, where things like user and device code are stored. The code is responded to the user, and the user is asked to start to open a device, a browser somewhere, and to log in interactively. While the user is starting this procedure, the set-top box is now continuously using the device code every 5 seconds to poll the device proxy whether somebody appropriately signed in over here. And as long as this is not the case, it will tell the device, the set-top box, it's pending. So the user now opens a browser, logs into the device portal, gets redirected to Azure AD, to Azure Active Directory, where they appropriately sign in. And once they get redirected back to the callback of the device proxy, the device proxy in the back talks to Azure AD, fetches a token and a refresh token, and stores these in the Redis database, and tells the user that the sign-in process is correctly finished. The device in the middle continues to poll here, and once a user has signed in, it has a proper access token and a refresh token in the database, so it can delete the entry and return the entry back to the device. So the device now has an access and a refresh token locally, the refresh token being valid for 2 weeks. The device can now use the access token to talk to the application, and it can also ask the device proxy to do a refresh on its behalf and get a new refresh and a new access token once an access token has expired. So let's just have a look at the implementation. So the implementation is a bunch of Azure functions implemented as a bunch of HTTP triggered Azure functions. This could also be living in a different, just in a pure web API. It doesn't really matter here. As mentioned, it's using Redis storage basically to be able to look pending authorizations up based on user code and device code, and to also update the state over here. So let's run this. I'm having so here I'm running my Redis instance to support the whole thing. Let's just kick off the application. So Control F5, this one. So now this is our device proxy. I'm using Visual Studio's dev tunnels, so I can actually host this site also on a real public endpoint. In order to demonstrate how it works, I'm having a shell script here, this demo.sh. This is effectively the code which would be executed by a device in whatever programming language you have over there. So by the way, one thing that is missing, so let's quickly have a look in the Azure portal, and let's pause the video while I'm signing in here. So in our Azure AD B2C tenant, we have 2 applications. We have a dummy API application. This represents our video API. This dummy app registration exposes an API, which is the video/watch API and scope. I have a second application which is the device code proxy, and this proxy has permissions to call into the watch videos API, and this is enlisted for the whole tenant. So this is basic, and this also has a credential which is being used by the web application. So if we now execute the code for the device login, so we want to sign in to this Azure AD B2C tenant, to this scope, and let's just have a look at the scope. So this is our tenant, our Azure AD B2C tenant, and the scope which we want to get access to is video API/watch, and also offline access, so we can have some so that we are able to refresh tokens. So the first thing now is we will be calling the public endpoint of our service here from our device and ask for a device response. So let's run this one here. So the message which the device needs to show to the user is to sign in at a certain location. So the user, I copy the user code into the clipboard and I launch somehow an external web browser, so that could be my mobile phone. And while the user is signing in, the device now goes into an endless loop to poll every 5 seconds in the backend whether the user has successfully authenticated or not. So now the user signs in. Let me just minimize this here. So the user signs in to the device portal, and so here either I use some social sign-in like GitHub, or I use a local user account which I have here. So let's do that. I sign in with my user account, and the sign-in is now successful, so this is no longer needed here. We can now have a look at the response. So the response from the device portal basically contains an access token, the ID of the resource and the scopes, and also a refresh token with which we can do things. So let's grab the access token and the refresh token and crack them up so we can look at what's inside. So inside the access token, I can see the name of the user, the scopes, which is the watch scope on the API, on our video API, so to say. What we can also do is we can do a refresh token grant type using our refresh token against the device proxy. So when we run this one here and we show like this one, so we can basically see like this mechanism also allows us to use the refresh token to update our access token and the refresh token together with the device proxy. So this is basically that last part here. Let me just make this bigger. So this is the green part where the refresh token is used to call again into the API.